Okay, so this is an honors geometry topic only, 10.3 and 10.5 areas of regular polygons. So, think of stop signs, and other types of signs I can't think of right now. They're typically regular polygons. They're not triangles, they're not rectangles. So, how can we find their area? Now, coincidentally, we are going to use a lot of triangles today to find these areas, but we're not going to use your typical area equals 1/2 base times height formula. We're going to talk about two different formulas for the area of a triangle. One is going to be very, very relevant for today's work. Okay, so here are your alternate formulas. So the first one is called Heron's, or sometimes Hero's formula. So there's a Greek mathematician that came up with this formula, and here it is to find the area of a triangle given all three sides, right? So if you have all three of its sides, so this is a side, side, side case, it's this formula right here. Area equals S, or square root of S times S minus A times S minus B times S minus C, where S is 1/2 A plus B plus C. We call this S the semi-perimeter, because it's half the perimeter. A plus B plus C would be the perimeter. You take half it, that's the semi-perimeter. Okay. There's also a formula involving trig when you have your side angle side situation. For side angle side, it's this formula. Area of a triangle is 1/2 BC sine of A. So BC, two sides, and then the angle in between, it's trig sine. So side, angle, side. Now, the first one is a little bit more difficult to prove. It involves some very hairy algebra. So we're not going to do that one, but we'll do the second one because it's pretty simple. Okay, so let's derive that SAS formula. So it is going to derive from the basic area formula. So area equals 1/2 base times height. So what we're going to do is we're going to draw a height in here. Okay. And let's go ahead and use A, so it'll match the formula. So the first thing I want to do is I want to uh, identify B as the base. So B is the base because it's perpendicular to my height. So it's just coincidental that I'm going to use B here, right? This B stands for base. This B is side B, okay? So we're going to use that. But now, to find what H is, I'm going to use trigonometry. I'm going to use sine. So if this is A, H would be the opposite side. C would be the hypotenuse. And then this bottom side would be the adjacent side. I don't care. So opposite and hypotenuse, that is sine. So the sine of A equals opposite H over hypotenuse C. And to solve this for H, I'm going to multiply both sides by C. I get C sine of A equals H. These C's cancel. Well, H is here, H is there. I can take C sine of A and plug it in for H. And area equals 1/2 BC sine of A. And that's how that formula comes about. Okay. So there we go. This is going to be very helpful today as we go through these problems. So be aware, we're going to use this. Okay, so here is a regular polygon. So I'm looking here at a hexagon, but and I'll highlight it in blue. Blue. You'll see that we're going to work with various ones. So here's the hexagon. So our goal is to find the area of these regular polygons. All right. So a couple things. You're going to have some different measurements given to you. First of all, you could be given the side length of the polygon. Secondly, you could be given what's called the radius. So this radius here, and notice the circle they drew, the radius just goes from the center of the polygon to one of the vertices of the polygon, okay? Now, if you notice, if you draw all of the radii, right, all of them, you'll notice how many triangles is this polygon broken into? Well, each side gets a triangle. So a hexagon, which has 6 sides, also is going to have 6 triangles, and they're congruent triangles. So we are going to focus on finding the area of one of those triangles. And once you find the area of one of those triangles, you just multiply it by the number of triangles there are, okay? Now, a couple other dimensions that they give you. One is called the apothem. It's this height of one of the triangles. We're really not going to focus on that. They might give you that, but I don't really care about the apothem. Um, the other thing we're going to have to use is what's called the central angle, right? So right there between two radii, that angle is called a central angle. Now, how are we going to find that central angle? Well, we have to understand that these six angles, make up that entire circle. Remember that a circle is equal to 360 degrees, right? That's my circle. So each of these triangles will have the exact same central angle by taking, so to find the measure of the central angle, you take 360 and divide by the number of sides, n. So if n is the number of sides, divide that. That'll get you your central angle. And that will be useful if we have to use trigonometry to find some things. Okay. But again, what is the long story short? The long story short is find the area of one of those triangles and then multiply it by the number of triangles to get the area of the polygon. Okay. So I'm going to stop this video now because that's a lot to take in. And we're going to do a couple problems in Elastic. I think it's going to be over 2 videos because these problems are not short to explain. Once you do them, I think you'll do them quickly, but to explain, they take a little bit of time. All right, very good.